All right. Hello, everyone. You're welcome back once again. My name is Victor Digomo here, and in our today's class, we want to see how we can find a much more practical way of teaching probability. Yes, the aspect we are going to cover is mutually exclusive events and independent events. Then we'll also take a look at probability of special cases. Then after then we can now look at you know um, binomial cases and all that. Okay, so please, you need to stay in this lesson because we are going to take it bit by bit. We are going to try the much we can within our possible best to help our students out there to understand probability. We are going to do some practical demonstration. Okay, we're going to do some practical demonstration that will help us to understand the probability. Okay, ordinarily, what is probability? Anytime we talk about probability, we talk about chance. We talk about chance, the chance of an event occurring, the chance of an event occurring. Okay, now this is a practical demonstration of a type of chance of an event occurring. Do we get that? Take for instance, if you look into this box I have in my hand, you can see inside this box. I don't know, look at it. You can see inside this box, or let me empty it here and then replace as you watch me. You see, this box is empty. This is an empty box. So I have inside this box three red balls. Three red balls. One, two, three. Three red balls. And five yellow balls. Five yellow balls. One, two, three, four, five. Five yellow balls. And we have also four blue balls. Four blue balls. One, two, three, and four. Four blue balls. Now, this box contains these balls of different colors. These balls of different colors. Now, if I close this box and shake, the essence of shaking is to remove bias in the selection. To remove bias in the selection. And I shake, and then I open the box and possibly close my eyes and randomly pick a ball. Of course, you can tell me what I picked. Did you see? This is blue ball. This is blue ball. So you see that this selection is as a result of chance. Is as a result of chance. There is no manipulation about it. Okay? It's as a result of chance. So probability is an aspect of mathematics that talks about chance events, the chance of an event occurring, the chance of an event occurring. And mathematically it is demonstrated as probability of, take for instance, this blue ball occurring, probability of blue ball occurring is just the number of blue balls in this box divided by or over the total sample space. The total sample space. The sample space we are talking about here is the possible outcomes. Okay, so one can begin to do some things. If you narrow this thing I have done here now, this practical demonstration I've done here now, if you narrow it down to, we can now use it to begin to talk about mutually exclusive events. Mutually exclusive events. Okay, now when do we say that events are mutually exclusive? When we say events are mutually exclusive, it simply means that the events cannot happen at the same time. Okay, the events cannot happen at the same time. Let me explain. I shake this ball again, shake this ball again, and then I randomly select a ball, and I'm seeing a yellow ball. You understand? This is a yellow ball. This is a yellow ball. It is not a red ball. It is not a blue ball. So as it is a yellow ball now, it is not possible. It is not no longer possible for this to be red. If this, as you are looking at it, turns to red, maybe you are watching a magic show in Who Got Talent. Maybe that's what you are watching, but we are not into that. That's not what we are doing here. In mathematics, we don't do magic. Yes, reality is what we are talking here. This is a yellow ball and nothing but a yellow ball. It is not a red ball. It is not a blue ball as we have in this place. Do you understand? So when we say that events are mutually exclusive, then it then means that if this is yellow, if I say in this selection I made now, it is either yellow or red. Yellow or red. It then means that yellow and the red cannot happen at the same time. Do we get that? They cannot happen. It is either it is yellow or it is red. That's this selection I just made. It is either it is yellow or it is red. The two cannot happen at the same time. You understand? We're also going to in the classes we are still going to do. We are still going to demonstrate independent events as well. Okay, and then we can also do some calculations around it. Now, as quickly as possible, another thing I want to demonstrate again is practically this. This is a die. This is a die. This is a die. And the chances that can happen here is 1 to 6. Because you see this side is 6. You see this side is 3. You see here is 1. So the possible chances that can happen here, when you randomly shake it and shake it and shake it and toes a die like this, you see what I am seeing here now is 3. Can you see that? It's just 3. Okay, it's just 3 that occurred. Is 3, and highest possible chances that can happen here is 1, 2, 3, up to 6, and nothing more, up to 6. So if this is a practical way of demonstrating tossing a die. When you toss a die, you see this one that just occurred now is 6 that occurred. Okay, so we can toss a die and see what is the probability of 2 or 3 occurring. 2 or 3 occurring. Such events are said to be mutually exclusive because it is either 2 occurred or 4 occurred. Do you get that? Yes, the two cannot happen at the same time. As I told this thing now, what you are seeing here is 6. And as it is 6, it cannot change to 5. If it changes to 5, it's now magic that we are doing here. I don't know if you are getting what I'm saying. We are not doing magic. So this is a practical way of, now, there are so many things we are going to do. And the best thing you do is to follow us in this class. We have a lot to do practically as possible in probability. And as you follow us, you watch us, cover mutually exclusive events with practical questions from WIC and NECO, JAMB, and thereabout, and other higher questions that you can be able to look at so far as probability is concerned. Okay, so this is my practical way of, demonstrating probability. Right now, what I want to do now is to delve into a little calculation around mutually exclusive events. Okay, stay there. You watch what we are going to do. So as I have demonstrated previously, we now know that the number of balls inside here, let me do it again. We now know that the number of balls inside here are how many yellow? 1, 2, 3, 4, 5 yellow balls. So we have yellow balls to be 5 in number. Okay, and yellow balls to be 5 in number, and we have 1, 2, 3, 4. 4 blue balls. 4 blue balls. 4 blue balls. B being 4. And we have 1, 2, 3 red balls. 3 red balls. 3 red balls. So R for red is 3. Now one can ask the sample space, okay, which is the space of all possible outcome. The space of all possible outcome here is, let's say, S being 5 plus 4 plus 3, and that is going to give us what? 9 plus 3, which is 12. 12. So the sample space is 12. Do we get? The sample space is 12. So I can, let me still hold it so that you don't think that I've done any manipulation with it. Okay. So one can be asked obtain to obtain the probability of a selection being being a, that is out of this. So A blue, B red or yellow. Okay, you just a demonstration of mutually exclusive events that cannot happen at the same time. Okay, C not 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 blue. Let me say not, okay, not red, because I'm seeing some other things here. Not red. Solution. So you can say that we have given the sample space. Do we get? And we have given the various possible outcomes. So you can see that probability of blue, P of B, will be number of blue all over sample space, or you can say total outcome, and also say that. So simply what we have here now is, what is the number of blue? We have 4. So that is 4 over 12, and that is going to give us 1 over what? 3. B, what again? Red or yellow. So probability of red or probability of yellow will be, of course, number of red there is 3 over the sample space, which is 12. Then plus, we are adding because these are mutually exclusive events. For mutually exclusive events, another way of explaining it is addition of probability. Do we get that? I said for mutually exclusive events, another way you can, or another way of explaining it is to say that it is addition of probability. So because we are going to add the probability of this and the probability of this, so we have probability number of y here is 5 over 12, and that is going to give us a total of course, here we have 12, and then 3 plus 5 will give us 8 over 12, and 8 over 12, 4 here is 2, and 4 here is 3. So the probability of red or yellow is 3 over 2. So it's just we're just going around mutually exclusive events. Now, when you Is there any other one? Okay, I didn't take number C. I've not taken number C. Look at number C here. It says not red. Probability of not red. Then if it is not red, do we get? If it is not red, then what is it? Okay, then it is going to be either yellow or blue. It's the same thing as probability of yellow. Yellow or blue. Okay, or probability P of blue. Do we get? Or in another mathematical way, you can say it is 1 minus probability of the not the others. So for your yellow now, this will be 5 over 12 plus, and then blue is 4 over 12. So we have it as 9 over 12. And 3 here will give us 3, 3 here will give us 4. So that is that. That is that. This is just a practical demonstration around mutually exclusive events. Mutually exclusive events. Permit me to also use the toes of a die to do another demonstration. I don't want this class to be too long, so please follow me in the next class. I want just to be brief. And if you see what we are doing, that it is useful, and we have added the knowledge to you, just give us a handshake. That handshake is just to click on the subscription button. And when you click on the subscription button, then and also the notification button, you will be notified when we make upload of other classes. And your subscription there is just to give us a handshake that, oh wow, you guys are doing well. I trust God you are going to do that. And then possibly you can also access other classes we have that is already there online. Thank you so much for being there.